So in this video, we will quickly define what a proportion is, and then we will use that information to help identify if what we have in front of us is a proportion, and also to determine what the missing part of a proportion is. So let's quickly define what the definition of a proportion can be written as. A proportion is a mathematical statement in which one ratio is set equal to another ratio. So we know what ratios are. Ratios are nothing more than a comparison of one quantity to another. So when we take one ratio and we set it equal to another, we know that we have a proportion. And the bottom set of examples are examples of proportions that we will need to solve for one of the missing quantities. So we'll get to that in a moment. But first of all, we want to establish if when we have two ratios in comparison to each other, as we have here, whether they are proportional or not. And although there are multiple different ways that different strategies that we can use, the strategy that I like to rely upon is using cross products, essentially cross multiplying. So we are simply going to take the 3 times the 34, and we're going to see if it is equal to the 51 times 2. So we know 51 times 2, if we quickly calculate that, 51 times 2 is 102. And if we go back and check 34 times 3, we will also verify that that cross product is 102. So if the two cross products equal each other, then we know that we have a proportion. So these are proportional when the cross products are equal to each other. So if we were to test the next one, if I were to quickly identify 48 times 4 and compare it to 18 times 9, if I get the same result, it will be proportional. If I get a different result, it will not be a proportional relationship. So if we quickly check 48 times 4, we know we will get 192 from that cross product. And if we do 18 times 9, we will get 162 out of that cross product. So those are not equal. So in this case, that would be not proportional. So that's all you need to do. You need to take your two ratios and you simply need to compare one cross product to another. If the cross products are equal, it will be proportional, as was the case in the first example. If the cross products are not equal, it will not be proportional. So sticking with this idea of cross products, we can now use that to our advantage to solve for the missing quantity in a proportion. What we're simply going to do is to cross multiply what we can and establish an equation out of that, and then solve for the variable in that resulting equation. So if I first do 3 times x, I know I get 3x. And then if I do 48 times 2, that's going to give me 96. And this should look very familiar to us because now what we have is a one-step equation. If I simply divide both sides by 3 to solve for x, then we know that 96 divided by 3 is 32. So the value of x that will make this a proportion is x equals 32. So x being 32 over 48 will be equal to 2/3. Now, if you think about that more deeply, what you would come to realize if you wanted to test it, you should be able to take 32 over 48. Although it's a ratio, we know we can treat it as a fraction, and we will discover that it will reduce down to 2/3 because both of these values are divided by the greatest common factor of 16. 32 divided by 16 is 2. 48 divided by 16 is 3. So that's how we know further that these are proportional, because in reduced form, they would also be equal to each other. So we'll solve one last proportion together. This one's slightly more challenging because of this because of this negative sign being part of the left side ratio. This is -3 to 4 is equal to 15 to x. We want to decide where this negative sign belongs. And out of habit, what I generally do is automatically bring that negative sign up to the top quantity. So I'm going to rewrite this as -3 over +4 is equal to 15 over x. And now I can go about cross multiplying by first taking my -3 times x, which is going to give me -3x, and set it equal to, because this is a proportion, the product of 4 times 15, which is 60. And the resulting one-step equation I could quickly solve by dividing both sides by -3, and I will get x equals -20. X equals -20. So once again, the missing value of x that completes this as a proportion is x equals -20, so that I know that -3/4 would be equal to -15/20 if we were to compare by reducing either or both ratios down and seeing that they're equivalent. So once again, we're relying upon this idea of cross products, not only to test if two ratios are proportional, but also to use cross products to solve for a missing quantity in a proportion that's been established for us. So the only difference is we're using cross products in the examples up above, where we have two ratios already provided to us completely, and we're testing if those two ratios are equal to each other by cross multiplying. If the cross products are equal, we will confirm they're proportional. If the cross products are not equal, we will confirm they're not proportional. And then when we go down below to the other set of problems, we notice one of our ratios is incomplete, but the cross products allows us to set up a one-step equation. And with our experience in solving equations, we can use inverse operations and solve for the missing quantity to make the proportion complete. So that is our quick introduction to proportions. And what I will ask you to do is a little bit of practice, confirming your understanding, and we'll come back to class and discuss more soon.